Hi, it's Jo Karen Hudson. In this video, we're going to be talking about multiplying polynomials. We'll start with the idea of the distributive property, which is something that we covered earlier in the modules. But we need to review that because we need to use it on example 2. The distributive property in example 1 would imply that we're going to multiply negative 4 times both of these. In other words, we're going to multiply negative 4 times 3y, and then we're going to multiply negative 4 times 7. Negative 4 times 3y makes negative 12y. Negative 4 times 7 makes negative 28. Now, we're going to have to use the distributive property twice on this next problem. You see, we're going to have to distribute the 7x with this one and this one. And then we're going to have to go back and distribute the 4y with those same two. And we call this FOIL. FOIL stands for first, outer, inner, and last. And I'll show you how that works. You see, when I multiply these two together, those are the first terms of each binomial. And when I multiply these two together, these are the outermost terms. And when I go back and multiply these two together, these are the innermost terms. And when I multiply these two together, these two are the last terms. So let's go back and FOIL these out, starting with these two. 7x times 4x squared, I'm going to write it all down to start off with. 7x times 4x squared plus 7x times 2x. And then the inside and the last would be plus 4 times 4x squared plus 4 times 2x. So my 7x times my 4x squared, 7 times 4 gives me 28, and x to the first times x to the second gives me x to the third, plus my 7 times 2 gives me 14, and my x to the first times x to the first gives me x squared, plus 4 times 4 gives me 16x squared, plus 4 times 2x gives me 8x. Now, I do have a pair of like terms here I will have to combine, so that I'll have 28x cubed, 14x squared, and 16x squared would be 30x squared plus 8x. Final answer on that problem. We'll be foiling on this next problem, and I'm going to continue to write it down, but I won't do that forever. We'll start off with the 4x times both of them. Let's see, 4x times 3y plus, and then the 4x times negative 8. And then we'll go back and multiply the 5 times both of them, so that we have 5 times 3y and 5 times negative 8. So that I have 4 times 3 makes 12, and x times y makes xy. 4 times negative 8 makes negative 32x. 5 times 3y makes 15y. And 5 times negative 8 makes negative 40. There are no like terms here, and so we do have a final answer. Now, we can't use the FOIL property on this one, but we can use that same strategy. We're going to multiply the 3t squared times all three of them, and then we'll go back and multiply the negative 2 times all three of them. Now, I'll not write this all out because it gets too cluttered when you do. So I'll start off, 3t squared times 3t squared would make 9t to the 4th. And then I'll multiply 3t squared times 3t. Let's see, 3 times 3 makes 9, and t squared times t to the first power would make t to the third power. And then 3t squared times negative 1 makes negative 3t squared. And then I'll multiply the negative 2 times all three of them. And negative 2 times 3t squared would be negative 6t squared. Negative 2 times 3t would make negative 6t, and negative 2 times negative 1 would make plus t, 2. When I add these, I'll have 9t to the 4th plus 9t to the 3rd. I'll have to combine these. Negative 3 and negative 3 would make negative 9t squared. Bring down the negative 6t and the plus 2. Final answer on that problem. Binomial products. A binomial is a polynomial with two terms. For example, x plus 2 is a binomial. The square of a binomial is a binomial raised to the second power. Or we could have x plus 2 squared. Conjugate binomials. Conjugate binomials are pairs of binomials with the same first and last terms, where one binomial is a sum and the other is a difference. An example of conjugate pairs would be x plus 2 and x minus 2. So we want to square the following binomials. We could start off reminding ourselves that 5 squared is 5 times 5, and that x squared is x times x, so that when we see our x plus 3 squared, we'll know that that's x plus 3 times x plus 3. Now, there is a formula you can memorize to do these problems, but I don't think it's necessary to memorize a formula when it's this easy to multiply out. So we're going to use our FOIL property again. The first and the outside. Let's see, the first would be x times x, which would be x squared. The outside would be x times 3, which would be plus 3x. And then we'll do the inside and the last. So we have 3 times x makes 3x, and 3 times 3 makes 9. So that we have x squared, the 3x and 3x add together and give us 6x plus 9. Squaring a binomial. On our next example, we have 7x minus 2y squared. We know that that means 7x minus 2y times itself, 7x minus 2y. So first we're going to FOIL it. 7x times both of those. 7x times 7x would be 49x squared. 7x times negative 2y would be negative 14xy. And then we'll do negative 2 times both of them, or negative 2y times both of them. Negative 2y times 7x would be negative 14xy. And negative 2y times negative 2y would be plus 4y squared. So that we have 49x squared. When we combine our negative 14 and our other negative 14, we'll have negative 28xy plus 4y squared. So we'll go on with conjugate pairs. Find the product of conjugate pairs, and we'll do this by FOILing as well. We'll multiply the first and the outside, and then go back and do the inside and the last. And you'll notice that something special happens every single time. When I multiply the first together, I have x times x is x squared. The outside would be x times y, which would be xy. The inside would be negative y times both of them. So we have negative y times x, which makes negative xy. We keep the terms alphabetized, the letters within the terms alphabetized. And negative y times positive y would be negative y squared. And what happens every time is that the outside and the inside terms drop out, so that we have x squared minus y squared. And you'll learn later that this is called the difference of two squares. We'll do another set of conjugate pairs, starting off 8x times both of them. 8x times 8x would give us 64x squared. 8x times negative 3y gives us negative 24xy. And then we'll multiply 3y times both of them. 3y times 8x gives us plus 24xy. And 3y times negative 3y gives us negative 9y squared. so that we have 64x squared, the outside and the inside drop out, minus 9y squared. And this is the last example. 3x times 3x, this is example 3. 3x times 3x makes 9x squared. The outside, 3x times negative 2y makes negative 6xy. When we do the inside and the last, we have 2y times 3x, which makes positive 6xy. 2y times negative 2y, which makes negative 4y squared. So we have 9x squared, the outside and the inside drop out, minus 4y squared. This is Jo Karen Hudson. Thank you, and have a wonderful day.